So now let's find the tangential and normal components of acceleration. So because we're talking about acceleration here, our function is going to represent position. So if r of t is the position vector for a smooth curve C, and assuming that your principal unit normal vector, your n vector, exists, then the acceleration vector, which remember we used a of t for acceleration, lies in the plane determined by the vector t and the vector n. And so basically what this means, this gets us that, so we can write the vector A, we can break it up into two pieces, a of t plus a of n, where this coefficient a of t, the way we find it, it's the derivative of the magnitude of the velocity vector. Or another way we can find it is it's the dot product of a and t. And if you need a third way to compute it, is it's the dot product of velocity and acceleration over the magnitude of velocity. And then so that's how we find this a of t coefficient, this a of n coefficient. It's the magnitude of v times the magnitude of t prime. Or you can also find it as a dotted with the n vector. Or another way to compute it is it's the cross product of velocity and acceleration, the magnitude over the magnitude of velocity. And then finally, one other way you can compute this is it's the square root of the magnitude of a squared minus a sub t squared. So let's find some of these values here. Let's look at our first example. Let's find the tangential and normal components of acceleration for the position vector given by r of t will be 3ti minus tj plus t squared k. So we're going to need to find the velocity, v of t. Well, that's the derivative of r. So it'll be 3i minus j plus 2tk. We're also going to need the magnitude of velocity. So then 3 squared 9 plus 1 plus 4t squared So we're getting the square root of 10 plus 4t squared. And then acceleration is the derivative of velocity. So we'll just get 2k. So now that we have these pieces, we can start finding our tangential component. So that's what we're going to start with first, is our tangential. That's a of t. So one way you can find this is it's v dot a over the magnitude of v. So if I take the dot product of v and a, you'll get 4t over the magnitude, which was the square root of 10 plus 4t squared. So here's my tangential component. Now we also want to find, we were asked to find the normal component. So that's a sub n. So in order to find that, I'm going to compute this cross product, v crossed with a. So I, j, k. V was the vector 3, -1, 2t. And a, the acceleration was 0, 0, and 2. So if you compute this cross product, you should get -2i minus 6j. So then, to get our normal component for acceleration, a sub n, it's the magnitude of v cross a over the magnitude of v. So the magnitude of v cross a is 4, square root of 4 plus 36 over the square root of 10 plus 4t squared. So we're getting the square root of 40, which is 2 square roots of 10 over the square root of 10 plus 4t squared. And there is my normal component for the acceleration here.